Now the next question states that a uniform meter scale of mass 60 grams. Now before moving on to the rest part of the question, I have to mark the mass of the meter scale 60 grams somewhere, and obviously I'll be marking it at the midpoint, which is the center of mass of the whole scale. So this would be 60 at the center. Now rest part of the question is something like this. A uniform meter scale of mass 60 gram has been loaded with masses 20 grams, 30 grams and 80 grams at points 10 centimeter, 20 centimeter and 90 centimeter. Where should this scale be balanced, or where should this scale be placed over the edge of a knife so that the scale or the meter scale is balanced? So we have to place a wedge at the bottom below it so that the scale can be balanced by these masses. Now what do we know about the moments? Moment states that the anti-clockwise moment is equal to clockwise moment. Now if I place my wedge here, obviously 20 has to balance 30, 60 and 80, which is not possible because that is more. Then if I place the wedge here, it will be 20 plus 30, 50 has to balance 60 and 80, again it is not balancing. So I have to place my wedge somewhere here because 60 plus 30 plus 20, which is 110, has to balance 80. So yes, this can be balanced because I can now adjust the distance if the weights are proportional in nature, right? So let us say we are placing a knife wedge somewhere here, okay, and this distance be distance x from the center of the meter scale. All right, so according to principle of moments, this 80 times this distance, I mean this distance, what would it be? 80 times what this distance would be. See, the 80 was placed at distance 90 centimeter on the scale, so it was already at how much from the center? 40 centimeter from the center. So I have to deduct this much distance because I want only this much. This hole was 40 centimeter, so I'll be subtracting the x from 40 to get this much part. So 80 times 40 minus x is equal to, what else is getting balanced? First of all, the weight of the whole scale, which is at distance x, 60 times x, plus then this 30 times how much this distance is. How much far is 30 from 50? It is at 30 centimeter, right? 20 centimeter to 50 centimeter is 30 centimeter. So 30 plus x, 30 plus x, and lastly we have this mass, which is 20, which was at distance of 10 centimeter. So 10 is how much far from this x? It is from 10 to 50 is 40, and 40 plus x. So this is 20 times 40 plus x. Now this is equal, now this is going to be balanced. So 80 into 40, 843200 minus 80x is equal to 60x plus 900 plus 30x plus 20 into 40, 42800 plus 20 into x is 20x. So I am taking all the x on the one side, basically I am bringing 80x here. So I will be left with how many x? One is 60x plus I have 30x plus I have this 20x, and lastly I have that 80x. And on the other side I have 3200 minus 900 and minus 800. So this is equal to 3200 minus 900 minus 800. How much is 9 plus 8? It is 17. So basically I have to do 3200 minus 1700, right? So instead of this I am doing minus 1700. I will be left with what? This becomes 2. This is 12, 7, 8, 9, 10, 11, 12. That is 5. 2 minus 1 is 5. So 1500. This is, so this whole becomes 1500. And how much is this? 60 plus 30 is 90. 90 plus 20 is 110. 110 plus 80 is 190. So 190x is equal to 1500. So x is equal to 1500 upon 90. Sorry, 190. So 150 over 19. This will be 7.92, or I'll 7.92, I'll be taking at 7.9. So this is 7.9 centimeters. So basically we have got the value of x. So where should the wedge be placed from the 0 centimeter? It will be 50 plus 7.9. So this is 57.9 centimeter. Okay. So the total distance is 57.9 centimeter.